Welcome to section 8.3. We're talking about inverses of a square matrix. Please remember a square matrix means that the order or the dimensions are the same for the number of rows and the number of columns. And so I'm going to start with the basic idea that if I give you an algebraic equation, such as 5x equals 30, what I can do in order to solve is divide both sides by 5. I end up getting then that x is 6. And what you'll notice is originally we're multiplying 5 times x. So I do the inverse operation, dividing by 5 in order to solve. Okay, well now I give you in part B a matrix equation. And so I give you 5 times a matrix x equals another matrix. Well, since we can't divide in a matrix, I'm going to multiply by 1/5 on both sides. So that I can solve this. And again, multiplying by 1/5 is the same thing as dividing by 5. So it's the inverse operation. And when I do that, I get this matrix that's 1, 2, 3, and 4 for matrix X. The last one, C, is the one that's the most important, and that's what we're working on today. I give you this matrix equation where we give you a matrix A times a matrix X equals this other matrix. And we need to do the inverse operation. And so what we do, and this comes back to the Algebra 2 idea, is we take the inverse of matrix A, and if I multiply it on both sides, then what it'll do is eliminate this A from each side and give me matrix X. And so matrix X is when I take A inverse times the matrix 5, 10, 15, and 20. And this kind of goes back to that idea we did in Algebra 2, where we gave you A times the matrix X equals a matrix B. And what we did is we multiplied A inverse on either side. And so we said then matrix X is the same thing as A inverse times B. And I think that probably looks familiar because that was our method for using our calculators to solve matrix equations. And so let's talk about the idea of an inverse matrix. If you multiply a matrix A times its inverse, you should end up with the identity matrix, which we call matrix I. Please remember the identity matrix means there are 1s in the diagonal and 0s everywhere else. But in order for an inverse to actually exist, you have to multiply A times the inverse to get the identity, and I'm going to underline that, the identity times A to get the inverse times A to get the identity as well. And so both have to exist. And so what we want to do is actually show you how that works. So I'm going to slide this up here a moment. And we want to be able to do both. So I give you two matrices, A and B. And if we want to prove that they're inverses, we have to show that the multiplication works in both directions. So I'm going to start by taking A times B. And if I do that, I get 1, -1, -1, and 2, multiplied by 2, 1, 1, 1. And if we remember our matrix multiplication from the previous section, we take the row times the column. And if I do 1 times 2 plus -1 times 1, I get the value of 1. First row, second column says 1 times 1 plus -1 times 1 equals 0. And I go second row, first column, -1 times 2 plus 2 times 1 is 0. And second row, second column says -1 times 1 plus 2 times 1, which is 1. And this is the identity matrix. So that's a good thing as we go through. Let's try the other way, though, because you have to prove that it works in both directions if they are inverses. So I start with B, and I multiply by A. And again, I go the same way. First row by first column. 2 times 1 plus 1 times -1 gets you 1. First row by second column, 2 times -1 plus 1 times 2 gets you 0. Second row, first column, 1 times 1 plus 1 times -1 is 0. And second row, second column, 1 times -1 plus 1 times 2 is 1. Again, this is the identity. Because you get the identity in both directions, you can say that A and B are inverses. Okay, and again, biggest thing, please keep in mind, you have to do both directions. in order to figure out that they are inverses. Okay, now, it's not that that's a difficult method, but again, there are going to be times when we're going to ask you to find the inverse itself, not just verify that they're inverses. This example is something that you will see on the quiz and the test, so kind of keep in mind. So let's take a look. What I know is that a matrix times its inverse should equal the identity. And I'm going to use that idea in order to be able to find the inverse. And so what I'm going to do is set up a system of equations. I'm going to let the inverse be a matrix, and I'm going to give it some random variables. And your book decides W, X, Y, and Z are the nicest ones to work with. You can pick any 4 letters. Those are just ones that we kind of use when we're doing this. Now I'm going to set up an equation. So I'm going to say my matrix A, 2, 1, 5, 3, times this matrix, the inverse, W, X, Y, Z, should equal the identity. And because each has an order of 2 by 2, my identity will be a 2 by 2 as well. And what I'm going to do is show that the multiplication will help me find the variables. So I'm going to write this down, and I'm going to put them in kind of 2 different places so that you can kind of see. 2, 1 multiplied by WY. So we're looking at first row, first column. That gives me the first row, first column value of 1. So if I look at this, I have 2W plus a Y should equal 1. Now when I do first row and second column, I'm actually going to move this up here so that I can kind of keep the variables separate. Now first row, second column is a value of 0. So I have 2x plus a z will equal 0. Okay, so I go back and do row 2. Row 2 in column 1 says I have 5w plus a 3y should equal the second row first column, so that equals 0. And the same thing, 5, 3, and xz means 5x plus 3z. This will equal 1 because it's second row column 2. So I've got to solve each of these. Now what I'm going to do is multiply this first one by -3. And let me slide this up a little bit just to give myself a little bit extra room. And if I do that, I get -6w minus 3y equals -3. So here's what I eliminate. So I get -w equals -3. Therefore, we know w equals 3. I can plug this back into an equation then to say 2 times 3 plus y will equal 1. Therefore, y has to equal -5. Okay, now I'm going to do the same thing for this next one. So I'm going to multiply this by -3. -6x minus 3z equals still 0. These eliminate. I get a -x equals 1. Therefore, x equals -1. And again, I'm going to plug it back in to get my y. 2 times -1 plus z has to equal 0. So if this is -2, if I'm going to add 2, I get then that z is 2. And what I have found then are all 3 values to go in my inverse. So my inverse then, and I'm just going to change colors so you can kind of see this, my inverse is w, which is 3, x, which is -1, y is -5, and z is 2. And so I end up getting this as my inverse by using the ideas that we did in Chapter 7 by using the elimination. And so this is one method of solving the, finding the inverse. And again, we are going to ask you to use this method on the quiz. So kind of be aware of that. Now let me show you another method. And I'm going to try and leave this actually up so we can see the inverse as we go through. But take a look. We're going to use what we call a doubly augmented matrix. And that means I take the matrix A and I augment it with the identity. And through Gauss-Jordan elimination, what I'm going to find is I get the identity on the left, and I will then end up with the inverse on the right. And so we're going to use the idea from 8.1 that we're using Gauss-Jordan elimination. So here we go. I'm going to go 2, 1, 5, 3, and I'm going to augment it with that 2 by 2 identity, so 1, 0, 0, 1. And I'm going to put my row operations down to as I would have in 8, 1. Okay, so I need this top left corner to be a 1, so I'm going to multiply 1/2 times row 1. And when I do that, I get 1, 1/2, I augment 1/2, 0, and then row 2 stays the same. Now that I've made a single X or a single 1 in the top left corner, I'm now going to start my Gauss elimination. So I'm going to take -5 times row 1 and add it to row 2, which means row 2 changes. So row 1 stays the same, and I know we're giving you fractions, but these at least are halves. We're trying to give you nice fractions. Please be aware you will have fractions that you will have to deal with, and this is a non-calculator idea. So let's go through. 1 times -5 plus 5 gets you 0. -5 times 1/2 is -5 halves. If I add it to 3, 3 is 6 halves, so I get 1/2. -5 halves plus 0 is -5 halves, and 0 plus 1 is still 1. Okay, so I've eliminated the X column, and now I want this value right here, this 1/2, to be a 1. So I'm going to multiply row 2 by 2 in order to make that a 1, which means row 1 stays the same. Let me fix that. So 1/2 augment with a 1/2 and a 0. And then I get 0. If I multiply it by 2, I get 1. By 2 is -5, and by 2 is 2. And now my last step is to eliminate. In order to eliminate the 1/2 up here, I need to take -1/2 times row 2 and add it to row 1. And I ran out of space on the side, but that's going to eliminate this value of 1/2 here. And so I'm just going to put it down here. Row 2 will stay the same, so 0, 1 augmented with -5, 2. And let's look at row 2. 0 times plus 1 is 1. Okay, -1/2 plus 1/2 is 0. There's our identity, which is beautiful. -5 times 1/2 is 5 halves, plus 1/2 is 6 halves, which is 3. And -2 times 1/2 is -1, plus 0 is -1. This then is our inverse. And what you'll notice if you look above, and I tried to leave it up there, is this is the same inverse as we found above, and you can see that up here. It's just a slightly different method. And again, this method will also be on the quiz and test, and we're going to ask you to show that you can find the inverse using both of the methods. And so kind of be aware of that. This is asking you really too, have you mastered 8-1 where you're using the elimination? So that's our idea so far. So let's try one that's a little bigger. All right, we give you a 3 by 3 matrix. So if I'm augmenting it, again, want to augment it with a 3 by 3 identity. So let's take a look at that. I have 1, -1, 0, 1, 0, -1, 6, -2, -3. And my 3 by 3 says put 0 or 1 in the diagonals and 0 everywhere else. Okay, so I'm going to shorten my eliminations here a little bit so you can kind of see, but what I'm going to do is take a negative of row 1 and add it to row 2 so that I have opposites to eliminate row 2. What that means is row 1 is going to stay the same. So 1, -1, 0, augmented with 1, 0, 0. If I add this negative to row 2 makes a 0, -1 makes it 1, plus 0 is 1, 0 plus -1 is -1, -1 plus 0 is -1, 0 plus 1 is 1, and 0 plus 0 is 0. Now you'll notice I haven't filled in row 3 because I'm going to eliminate row 3 at the same time. So because it's a positive 6, I'm going to say -6 for row 1, and I add it to row 3 this time. And if you're getting pretty good at this elimination stuff and want to do that, that's fine with me as long as these are there so that I know what you are doing to each row. So negative 6 plus 6 makes 0. Positive 6 and negative 2 is a 4. 0 and negative 3 is negative 3. And then we augment. Okay, so negative 6 and 0 is negative 6. 0 and 0 make 0. 0 plus 1 gives me a 1. Now I've eliminated the x's, so I want to use row 2, because that's the y row, to then eliminate the y's. So what I can do is add row 2 and row 1, because they're already opposites. And so let's do that. That means row 2 in this case is going to stay the same. Negative 1, 1, and 0. Okay, so here we go. If I eliminate row 1, 0 plus 1 is still 1. 1 and negative 1 makes 0. Negative 1 and 0 makes negative 1. Negative 1 plus 1 makes 0. 1 plus 0 is 1. 0 plus 0 is 0. I'm going to do the same thing again, and I'm going to try to eliminate the 4 at the same time. So I'm going to take negative 4 times row 2 and add it to row 3. So if I do that, here's what I get. Negative 4 plus 4 is 0. Positive 4 and negative 3 is a 1. Positive 4 and negative 6 is negative 2. Negative 4 and 0 is negative 4. 0 and 1 makes 1. And you'll notice my third row is beautiful. And so that's already worked its way out to tell me what the bottom row of my inverse will look like. So my last step is to eliminate the z's, and if you notice, they're already opposites, so I can take row 3 plus row 1 to eliminate, and row 3 plus row 2 to eliminate. And so I'm going to just show you that as we go through. That means row 3 is going to stay the same, so negative 2, negative 4, and 1. So let's go through. I'm going to add to row 2 first. So row 3 plus row 2, let's start there. You get 0 plus 0 is 0. 0 plus 1 is 1. 1 and negative 1 is a 0. Negative 2 and negative 1 makes negative 3. Negative 4 and positive 1 makes a negative 3. And 1 plus 0 makes a 1. I'm now going to add row 3 and row 1 so that I can eliminate those. So 0 plus 1 is 1. 0 plus 0 is 0. 1 and negative 1 makes 0. There's my identity. Negative 2 and 0 makes negative 2. Negative 4 and 1 is negative 3. 1 and 0 makes 1. And so this is my inverse. So what I have found is the inverse matrix is negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. And what you could do, again, is to check that you get this as your inverse in your graphing calculators just to verify that you're on the right page. But again, we're going to ask you to use that doubly augmented to show that you end with the inverse and your identity. Last example wants to go back to the Algebra 2 version of solving, and this is a calculator question. Now remember, quiz 8.1 to 8.3 is a no calculator quiz, but your test does have a calculator portion. And so we want to set this up. And what we said is you set up an equation, a times x equals b, where a is the coefficients, x is the solution, b is the constants. And so if I look at just my coefficient matrix, because I have an x, y, and a z, I know it's a 3 by 3 matrix. So I've got 1x, negative 1y, 0 z's. 1x, 0 y's, negative 1 z's. 6 x's, negative 2 y's, negative 3 z's. I'm multiplying by that matrix of my solutions. I'm trying to find the values of x, y, and z. Equals whatever the constants are, negative 1, negative 2, negative 6. And we said in Algebra 2, in order to solve this, you multiply both sides by the inverse. Now what's important is what happens here on the right side, because I have to multiply the inverse first in order for my dimensions to match to be able to multiply. So what you'll need to do in your calculator is find A inverse and then multiply it by B. And this is one that we want you to put in your calculator and then come to class with an answer. So x, y, z equals, I'm looking for this matrix. Tell me what it is, and that's the end of this section, section 8.2. So we're looking at this, and hopefully this helps again with finding inverses. Please know again, though, as I scroll up here what's on the quiz, you will have a doubly augmented matrix. You will have to find it using systems of equations, and so just kind of be aware. So that's section 8.3. Bring questions and concerns that you have to class, but also start the homework and see what you can do there.